Today we're going to look at topic 6.4, modeling data using exponential functions. It's from page 370 in the textbook. What we're going to do is start, if we're given a table of values, we're going to use our graphing calculator and we're going to come up with a graphical model and an algebraic model for the data. After boiling a pot of water on the stove, Heather measured the temperature as it cooled. Here we have a chart, time in minutes, temperature in degrees Celsius. The first time she measured, it was 80 degrees. After 5 minutes, it was down to 69. After 10 minutes, it dropped to 61. 20 minutes, 45, and so on. Now, what I want you to do is enter the X values into L1, enter your Y values into L2, set your windows. If you look at your X values, they go from 0 to, let's go to about 60, and we'll increment. Our scale will be every 5. Our Y values go from 0 to 90, and we'll put a tick or have our scale every 10. Now we have to turn our stat plot on by pressing second function, y equals, and on. Now what you've done is created a scatter plot. By looking at it, you can see that it's going to be an exponential function. And it's a decreasing exponential function. So we can use exponential regression to determine an equation that best fits our values. And when we place stat, the right arrow, 0, and enter into our calculator, it'll give us the curve of best fit. This equation that we get, we're going to round it to 3 decimal places and put it into our equation into y1 equals. And you're going to watch as you draw it and press graph. It's going to pass through most of our points on our scatter plot. Our equation is y equals 79.888 times 0.972 to the power of x. Questions. What will be the temperature after 25 minutes and after 60 minutes? Well, you can read this information from your graph, but you must first turn your stat plot function off. Otherwise, it's not going to read between those points. Once you turn them off and you have your y equation in, now you can trace it. You can press graph, trace, 2.5 or 25, and enter. Your calculator should tell you that x is equal to 25 and y equals to 39.3. Now that 39.3, that's degrees. If you press 60 enter now, and your calculator will say x equals 60, y equals 14.5 degrees. So after 60 minutes, the temperature will have dropped all the way down to 14.5 degrees. How long will it take, number 2, for the water temperature to hit 40 degrees Celsius? Well, we have to interpolate this information, or we can calculate it trace it from our graph. We already have y1 is equal to 79.888 times 0.972 to the power of x. So we're going to set y2 to equal 40. Now we've got a graph that has 2 graphs on it. One will be a straight line and one will be our original function. What we're going to do is find the intersection point of the 2 graphs. That intersection point is going to give us our answer. We know that y is 40. This x value of 24.358 tells us that, it's going to be 24.4 minutes before the temperature reaches 40 degrees. How do we find this? Well, if you press second, trace 5, and then enter 3 times, you're going to get x equals 24.4. Your assignment is page 377, numbers 1 to 9.